Today we're going to be talking about exponent rules. And so we'll start by just, taking numbers to exponents. So 5 squared is like 5 times 5, which is 25. Okay. And as we do the rest of these, you'll see that pretty much throughout this unit, we're not going to be solving very many equations. Solving is a huge focus of this course, but in order to solve some of the more advanced objects we're going to encounter later in the year, higher degree polynomials, radicals, fractions, stuff like that, we're going to need some of our exponent rules and just other algebra rules. So what we're going to do today, we're doing the exponent rules. Next time, we're going to do arithmetic with polynomials, which basically is combining like terms and distributing, or what y'all might call FOIL. And then the last 2 times were factoring. We'll do a lot of factoring. So this is just like getting us the tools we need to attack the problems we've got coming our way, really for the rest of the year. All right, so 2 to the 4 is 2 times 2 times 2 times 2, which is going to be 16. 3 to the 1 is just 1 power of 3, which is 3. And then over here, we've got a couple of these that are often confused. Okay. So what you got to remember is the order of operations. Remember, parentheses comes first, then exponents, then multiplication and division, then addition and subtraction. So over here, when I do negative 2 squared, I need to take the exponent before multiplying by negative 1. Okay, so that's going to be negative 4. Another way you could look at this is when you make something negative, really what you're doing is multiplying by negative 1. So you have negative 1 times 2 squared is 2 times 2, which is negative 4. Over here you have negative 2 times negative 2, because you're squaring negative 2, and that's going to be positive 4. Okay, now we'll bring in some variables. And so x squared is, okay, you square a thing, it's really just multiplying by itself, so that's x times x. X to the 5th is 5 powers of x. 3x squared y to the 5th. Okay, well, I'm just multiplying 3 by x squared. And then I'm multiplying by y to the 5th. It's going to be 5y's. Over here, if I take x squared and I square it, I'm just multiplying x squared by x squared. Okay, and then if I write out all the x's and then go to count, I have x times x multiplied by x times x. That is a total of 4 x's. Over here, I've got 3x squared y to the 5th squared. So I need to multiply 3x squared y to the 5th by 3x squared y to the 5th. I think now would be a good time for me to point out 5 times 4 and 4 times 5. Same or different? Same, yeah. So we can multiply in whichever order we like. Meaning that I can take these 3's and push them all to the front, put the x's together, and put the y's together. Okay, so that's 3 times x squared, y to the 5th, and y to the 5th. Okay, so 3 times 3 is 9. I'll just deal with that now. X squared times x squared, well, I did that over here, and that was x to the 4th, so I'll just do that now. But I don't know if I got that by adding those exponents from my multiplying. So what I'm going to do is I'm going to take that y to the 5th and y to the 5th, and I'm just going to, y to the 5th is 5 powers of y, and then I'm still multiplying by 5 more powers of y. And if you went and counted all of them up, you would have a total of 10 powers of y. So this is 9x to the 4th, y to the 10th. And so at this point, I feel like we need some general rules to move forward with our, with all of these simplifying problems. Okay, so first we're going to look at what happens when I multiply something with the same base and a different exponent. Like maybe I'll start with x squared times x to the 3rd. Okay, and maybe you know what this is, but maybe you don't exactly remember why we do what we do to those exponents. Okay, well what you do is you list out the x's. That's x times x multiplied by x cubed is x times x times x. In total, I have You know, if you count how many x's you have through here, you have 5 total x's, so that means you have x to the 5th power. How would I have gotten x to the 5th using x squared and x to the 3rd? Using the 2 and the 3 to get 5, you add them? Yes, okay. So x to the a times x to the b is equal to x to the a plus b. Okay, that's general rule. Okay, now we're going to divide two things that have the same base but different exponents. So I'm going to go over here and I'm going to look at x to the 5th divided by x to the 3rd. Okay, well, I'm going to list out all the x's, so that's 5 powers of x. And over here, I'll have 3 powers of x. And something to remember that, okay, if I look at like 84 divided by 84, what is that? 1, yeah, okay. So that's 1. And in general, if you have anything and you divide it by itself, that's going to be 1. Anything except for 0. 0 divided by 0 is not 0. It's not 1. It's not a real number. Okay? There might, maybe later in the course, we'll see that 0 over 0 isn't really the end of the world, that we can kind of work with it. But for now, 0 over 0 isn't defined. But I don't see any zeros here, so nothing to worry about. Yes? Okay, so let's look. Okay, over here I'm seeing x divided by x. That's just 1. Here I have another x divided by x. That's 1. Another 1. Okay, so what this is 1 times 1 times 1 times x squared, which is just x squared. Okay, so how would I get from x to the 5 divided by x to the 3 to x to the 2? What do I do with the exponents? You subtract them, yes. Okay, so x to the a divided by x to the b equals x to the a minus b. Okay, so that's the general rule, but I've got more to say about this. Okay, let's look at maybe x squared divided by x to the 3rd. Okay, well, using our shiny new subtraction rule, I'm going to say that's x to the 2 minus 3 equals x to the negative 1. But if I go in and actually write out the x's for x squared divided by x to the 3rd, what I'm going to have, well, x squared divided by x squared. That's just 1. So I'm going to have 1 over x. So another thing I have is that x to the negative 1 power equals 1 over x. That's going to be a big one today and moving forward in this class. The negative exponent essentially is going to flip a fraction. Okay, while we're at it, we might as well hit the power of a power property as well, even though it's going to be a while before we're really going to need to use that, I think. Okay, so if you have x to the 3rd and we square it, kind of the question is that going to be x to the 5th? Is it going to be x to the 6th? Is it maybe going to be x to the 9th? Do we take 3 to the 2nd power? Do we multiply them? Do we add them? Who knows? Okay, so what we're going to do is we're going to write out the actual x's. Okay, we have x to the 3rd times x to the 3rd. And you could say, all right, well, you just showed me that addition property, and I'm going to add those. Or you could actually list out all the x's if you really want to be sure. Mm-hmm. Yes, that's what's going to happen, is we're going to end up multiplying them. Okay, so we have, in total, 6 powers of x. Yeah, thank you. All right, and so that's going to be x to the 6. Okay, so in general, we have x to the a to the b power is equal to x to the a times b. Okay, so there's actually one more that we're going to need. Power of a product. So let's look at what happens when we take like a times b and we square it. Okay. That's going to be ab times ab. And again, I said that 4 times 5 is the same as 5 times 4, so we can multiply in whatever order we like. So I'm going to have a times a multiplied by b times b, which is a squared times b squared. So what I'm saying is that you end up distributing the 2 to the a and the b, but only when you have multiplication on the inside. Okay? One of the probably biggest classic algebra errors is trying to distribute an exponent over addition. You cannot do that. Okay? That's next time. I will be all over y'all about that next time, but I think you all will be fine with it. They were fine with it last year. But for now, we're only dealing with things multiplied together. You'll see no addition today. And so I think that's going to be all the properties that we'll need to solve some of these, or at least simplify some of these expressions. Okay, here we've got some examples. And so what the instructions will say next time on the quiz is simplify the expression, no decimals, no negative exponents. Okay, I don't think we really need to worry about decimals right here, or you shouldn't either on the quiz, because it's one less thing to worry about, Over here, okay, x to the negative 4. Okay, a negative exponent. We weren't ready for x to the negative 4. Okay, we need to go over here and look at the 0 and negative exponents. Okay, so 3 to the 3. Does anybody know what 3 to the 3 is? Yeah, 27. Okay, 3 to the 2 is 9. 3 to the 1 is 3. Okay, but then what about the 0 power, the negative 1 power, the negative 2 power? Okay, so let's look at the pattern and see, how do you get from 27 to 9 and from 9 to 3? Well, we're just dividing by 3 both times. So when I go to 3 to the 0, I'm going to divide by 3 again. And 3 divided by 3, what is 3 divided by 3? Anything divided by itself is just going to be 1. Yeah, well, eventually, yes, we'll get to 1/3. Okay, so this one's going to be 1. And then I'm going to divide by 3. Take 1 divided by 3, and, well, that's 1 divided by 3. And then if I go again and divide by 3, we have 1/3 of 1/3, which is 1/9. Yes. Yes, exactly. Okay. So over there, 554 was drawing the comparison between 3 to the 2 and 3 to the negative 2. Okay. The difference between 3 to the 2 and 3 to the negative 2 is that it's 9 versus 1/9. Now, like I said before, that negative exponent is going to turn it into a fraction, or if it's already a fraction, it's going to flip it. And then the square is still squaring the 3. It's just becoming 9 in the denominator. Okay, the rule for 0 exponents, and now we'd already talked about this a little, I think, or maybe no, we just saw it up here, was that 3 to the 0 is 1. Okay, so we've got 3 to the 0 equals 1, but why is that true? Okay, we've got our subtraction property for exponents, so let's use that. What if we had, x squared over x squared? Well, that's x to the 2 minus 2, which is x to the 0. But I know that anything divided by itself is going to be 1. Okay? So x to the 0 is 1 because anything divided by itself is just 1. Rule for negative exponents. Okay, so I guess I would put over here, or maybe in green, the general rule is x to the 0 equals 1. And, I'll tell you that's just true as long as x is not 0, but you won't have to worry about that this unit, I don't think. Rule for negative exponents. Okay, well, up here we saw that 3 to the negative 2 is 1/9, which is 1 over 3 to the 2. We could also look at this as this is equal to 3 to the 0 minus 2, which is 3 to the 0 divided by 3 to the 2. 3 to the 0 is 1, so that's 1/9. In general, x to the negative a power is going to be 1 over x to the a. And the rule for negatives with exponents, we've kind of already gone over that. Just remember to be careful about your order of operations. That exponents comes before multiplication by negative 1. Okay, so now we're ready to move on and simplify some expressions. So when I go to look at 1 over x to the negative 4, I'm going to say that's 1 over x to the negative 4 is 1 over x to the 4. Okay, so I'm going to rewrite the numerator. 1 is just 1 divided by 1, divided by 1 over x to the 4. So I've got okay, and when we divide two fractions, we flip and multiply. Okay, so I'm going to say that's the same as 1 over 1 times x to the 4 over 1, which is just x to the 4. So we see that that negative 4 is actually just going to send it back up to the top and become x to the 4 in the numerator. Okay, and as far as this stuff goes, maybe wherever you went to school, they call it maybe keep, change, flip. I've heard a bunch of, names or tricks for that. But really, it comes down to dividing is just multiplying by the reciprocal. So if we're dividing by 1 over x to the 4, we're really just multiplying by the reciprocal of 1 over x to the 4, which is x to the 4 over 1. Okay. Okay, so here we got a couple of more examples, and I'm going to just start off for you. X to the 8 times x to the 4, that is x to the 8. What do I do with the 4? Do I add it? Do I multiply it? Do I divide it? Yeah, I'm adding it. And that's x to the 12. Okay, over here, this is going to be x to the 2, 3, and 6. It's going to be x to the 11. Okay, so y'all do the rest of these real quick, and then check your answer against mine. Sounds too crunchy. It doesn't sound like you're doing your examples. What kind do you have today? Salt and vinegar. Salt and vinegar. Nothing wrong with that. Okay, so these are kind of dealing with the power of a power property. So I'll start over here. This is where we're going to multiply the 2 and the 2. So this is x to the 2 times 2. But maybe I'll change this a little bit to make it maybe x to the 2 to the 5th power. So that'll be x to the 2 times 5, which is x to the 10. Okay, over here, just to remind you why we're going to need to distribute that square to everything, we're going to square 2xy. And notice when I do that, I have 2 of everything. I have 2 2's, I have 2 x's, I have 2 y's. So that's 2 squared x squared y squared. So that's 4x squared y squared. Okay, y'all do the rest of these. Check your answer against mine. Okay, so question was, the one in the bottom right, how are we getting that 16 over 27? So let's just kind of start over. So I'm going to say that I'm going to take everything to the fourth power. I'm going to take 2 to the fourth and a to the 3 to the fourth. A to the 3 to the fourth is going to be a to the 12. Okay, and then I'm going to take everything over here to the negative third. So it'll be 3 to the negative third times a to the negative 2 to the negative third, which will be a to the positive 6.
How'd you get 64? Yeah.
Okay, and now that I've got this, I'm going to put all the numbers together and all the variables together. Okay, so a to the 12 times a to the 6 is where we're going to add the powers, and that's going to be a to the 18. And then, okay, 2 to the 4 is 2, 4, 8, 16. And 3 to the negative 3, remember that x to the negative a is 1 over x to the a, so this will be 1 over 3 to the 3. Which, when I look more closely, is going to be 16 over 1 times 1 over 27 times a to the 18, which is how I got 16 over 27. Okay, now we're going to look at some division, but this is really going to be all of the rules put together. Okay, so x to the 2 over x to the 5. Remember that if we have division of the same base and different exponents, that's where we subtract the exponents. So that's x to the 2 minus 5 is x to the negative 3, which is the same as 1 over x to the 3. For the next one, I've got, okay, a to the negative 5, b to the 3 over ab taken to the fourth. Okay, so what I'm going to do is I'm going to deal with that parentheses on the bottom. A negative 5, b 3. This is a to the 4, b to the 4. Okay, so this is a to the negative 5 minus 4 times b to the 3 minus 4. So a to the negative 9, b to the negative 1 is going to be 1 over a to the 9 multiplied by 1 over b. It's going to be okay. So y'all work the one on the right and then just check your answer against mine. Alright, so I'll do the one on the left, y'all do the two on the right. So this is m to the 5, n to the negative 4. I'm going to deal with the thing in parentheses, so that's m to the 10, n to the negative 1. So this is m to the 5 minus 10, and n to the negative 4 minus negative 1. Okay, so this is like 1 over m to the 5 and n to the 3. So y'all do these two. You definitely want to be able to do the one in the middle. That one looks super familiar to me. Alright, so here we have something like power of a power, except we've got fractions, we've got all sorts of stuff going on. So, since everything here is multiplied together, I'm going to be distributing the third power to everything. So this is 2 to the third, x cubed to the third, divided by 3 to the third, y to the third, z to the third. Okay, 2 to the third is 8, 3 to the third is 27, so that's 8x to the 9, divided by 27, y to the 3, z to the 3. Okay, the one on the right is super similar, so why don't y'all try that? This is one that's definitely like right in our good zone of problems we can solve. Okay, so this one I'm going to start with 1/3 and I'm going to square it. Well, 1/3 times 1/3 is 1/9. Or you could say it's 1 squared over 3 squared. Same thing. Over 3 to the third, x cubed to the third, y to the negative 2 to the third, or x squared to the third, y squared to the third. We're taking power of a power, that's where we're going to end up multiplying the exponents. So there's going to be a lot of multiplying of these. Right? So I've got a lot of powers, and I'm taking them all to some kind of power. So this is 3 to 3 is 27. X to the 9, y to the negative 6, over 9, x to the 6, y to the 6. Okay, so 27 divided by 9, that's 3. X to the 9 minus 6, y to the negative 6 minus 6 more. Okay, so that's going to be 3, x to the third, and y to the negative 12 becomes y to the 12 in the denominator. Okay, so I've solved this one maybe a little differently than the other ones. You know, it's all equivalent. But when I saw both of these things had a negative exponent, it's like, well, maybe I could just flip the fraction and make the exponent positive on the outside. So that's what I did. I took the 3a over 4b, I flipped it to deal with the negative, and then I'm going to square it to deal with the 2. Over here, on this one, I flipped the fraction, and now I'm taking it to the first power, which is basically do nothing with it. And so I've got 16b squared over 9a squared multiplied by 3b squared over 4a to the third. So you want to deal with the numbers first. Okay, I see that 16 and 4, have a common factor or something they can cancel. Okay, that's the same ratio as 4 to 1. And then 3 to 9 is the same as 1 to 3. And then past that, I'm just using my exponent properties. Okay, so the last thing we've got is some geometry problems, basically. Okay, we've got a rectangle, so I'm going to draw a rectangle. With length 5w squared and width 7w. Okay, what's the area? Well, the area is going to be where I just multiply the length and the width. Okay, and we can multiply in whatever order we like. 5 times 4 is 4 times 5. So that's 5 times 7 times w squared times w. Yep, 35w to the 3, yes. Okay, so if they asked us to find the area of this thing, well, maybe I would just deal with the parentheses right off the bat. That's going to be 2 to the 2 times x squared to the 2. So that's going to be 4x to the 4. Okay, so I can just say that the height is 4x to the 4. If they ask us to find the area, we know that the area of a triangle is 1/2 times the base times the height. So that's going to be half times 12xy times 4x to the 4. Okay, so I'm going to deal with the numbers first. Half of 12 is 6. 6 times 4 is 24. Then the x's, I've got 1x and 4x is 5x's. And just one y. Okay, so that's the area. It's 24x to the 5th multiplied by y. Okay, for a square, we know that square has the same two side lengths. So that's 7x squared y to the 3rd. Over here I have 7x squared y to the 3rd. So area is so I'm going to square everything. That's going to be 7 squared is 49. X squared squared is x to the 4. Y to the 3rd squared is y to the 6. Okay, so if we had a circle with radius a squared b to the 3rd, well, we know that the area of a circle is equal to pi multiplied by the square of the radius. So in this case, the area is going to be pi multiplied by a squared b to the 3rd squared. So it'll be pi times a to the 4th times b to the 6th.